Yes, thank you students. Now I will teach you about the fourth unit. Okay, fourth unit there. Now, what is an algebraic system? Algebraic system is a set with one or more operation is called algebraic system. So for example, S comma F1 comma F2 dot Fn inside the bracket. This is a good example for algebraic system or algebraic structure, we say. Now let us take this example. It's also an algebraic structure where x is a set, dot is a one binary operation, and star is another binary operation. Now example 3, x, what is that? Multiplication and plus. This is also another example for algebraic structure. Now, properties of algebraic structure. First one is called associative. Associative is a first properties of algebraic structure. What is that property says? If A, B, C all belongs to the set X, then A plus B plus C equals A plus B plus C. See how the right hand side and the left hand side are associated. The left hand side, the last two elements are associated. On the right hand side, the first two elements are associated, but still both are equal. This property is called associative property. This is as far as plus is concerned. This is another operation, and that also associative property is satisfied. Okay, now let us take next page now. Right, now let us take this. Next property is called uh, commutative property. For any two elements A comma B belongs to the set X, A plus B equals B plus A, or A cross B equals B cross A. Okay, and this property we call it as commutative property. Then identity element. There exists 0 belongs to X such that any element by adding that element 0 will get the same element, and this property is called identity property. And then inverse element, for any A belongs to X, we have minus A belongs to X in that structure such that minus A plus A equals 0. That is, when we add the inverse with the same number, we'll get 0. This property we call it as inverse property. Now let me take this inverse property. So totally how many properties are there? We studied here about associative property, commutative property, identity property, and inverse property. So these are some of the important properties of algebraic structure. Now I will give you a lot of examples for algebraic system or algebraic structure. The first one is or comma plus comma multiplication, where or is set of real numbers, plus is the addition, and this is the multiplication. Right. Similarly, integer. Now look at this, the integer. integer, plus, and multiplication as we define in our number system. This is also a good example for algebraic structure. N set of natural numbers plus addition and multiplication is also another example for algebraic system. Similarly, in the set language, our set of any set with union and intersection is another example for algebraic system. And now look at this. This is also a good example for algebraic system where x is taken as 1, 2, 3, 4 and f is a function from x to x where f power star is defined like this. So this is a good example for algebraic system and that satisfies all the above properties. Okay. Now the continuity of that. Now what is a homomorphism? What is a homomorphism? And before that, if okay, we'll study first homomorphism. Afterwards, study about monoids. Let x dot and y star be the two algebraic system. Binary operations are here. A mapping from G to a mapping G from x to y is called homomorphism if it has to satisfy this condition, that is, for all x1, x2 belongs to x, we should have g of x1 dot x2 equals g of x1 star g of x2. In this case, y star is homomorphic image of x dot. Thus, the homomorphism. Homomorphism G is from x to y is to satisfy this condition. For all x1, x2, the image of G under x1 dot x2 must be equals G of x1 star G of x2. Now what about epimorphism, monomorphism and isomorphism? Now let G is a homomorphism. G is a homomorphism from x to y, you suppose, and to y comma star, x comma dot to y comma star. If G is onto, then it is called epimorphism. Here is a homomorphism. If this homomorphism is onto, then it is called epimorphism. If G is 1 to 1, it is called monomorphism. This homomorphism is 1 to 1. Each element have only one images. That's called 1 to 1. It's called monomorphism. If G is a homomorphism, both 1 to 1 and onto. Onto means all the elements in the second set have three images in the first set. So if the homomorphism is 1 to 1 and onto, then it is called an isomorphism. Okay. If G is isomorphism between x dot and y star, then they each are called isomorphic. That is, x dot and y star are isomorphic. This is isomorphic to this and this is isomorphic to this. And now let me take the next page. This is what we say endomorphism and automorphism. Endomorphism and automorphism. What is that? we'll see now. Now, look at this. Endomorphism and automorphism. If x dot and y star are two isomorphics, if y belongs to y is contained in x, then G is endomorphism. If y equals x, then G is called automorphism. Okay, this is a good example for that. If x is a set given to us 1, 2, 3, 4, and if f is a function from x to x given by star is an example for isomorphic, and x are isomorphism to one another. Similarly, we can take this example. Let S is a set consists of A, B, C, and star be binary operation, and the P is another set 1, 2, 3, and round plus be binary operation where in the set P. Then we can show that S star and P round plus are isomorphic to one another because they satisfy all the conditions for isomorphic. Now if you take, let G is equal to S to P given by G of A is equal to 3, G of B equals 1, G of C is equal to 2, then the condition for isomorphism is satisfied. Therefore, we can say that these two are isomorphic to one another. Isomorphism means what I told you just before, that there is both one-to-one and on-to, that it is isomorphic. So the graph or the matrix or the function from S to P defined by this between the two sets S and P is called isomorphism. Now let us have a continuation of this, and that comes here in this page. Semigroup and monoid. What is a semigroup and what is a monoid? The algebraic system S dot is called semigroup. The operation is associative. Then we say that the structure S comma dot is a semigroup. Now what is a monoid? In the semigroup M comma dot, if there exists an identity element, then we say that structure M comma star is called a monoid. Otherwise, in mathematical way, we can say like this: commutative, and it should have an identity element. So commutative means x dot y dot z equals x dot y dot z. And second condition, there should exist E belongs to M such that E of x equals x dot E for all x belongs to M. There should exist a single E. So these two conditions are satisfied in a semigroup, then it is called monoid. Okay, and the example, we can take this. It's a good example in the set language. Power set of S with the intersection and power set of S with union. These two are monoids with identity elements pi and S. And if it is monoid, automatically it is semigroup. Okay, so with that I come to the end of this class. The next class we will see other things.